The Raspberry Pi 5 was about 3 times faster than the 4, and it still came with its SD card adapter, but if you buy a large case for sort of $30-40 euros, you can put an NVMe in there directly on the PCI lane, and that makes the storage a lot quicker. This also works on a compute module, and then I have a machine already plugged in. The Raspberry Pi has 16 gigs of RAM. So just to show you that, there's the 16 gigs. We have a NVMe in here with 12 gigs of RAM storage, and that is used as the root drive. I have deliberately cleared out the containerd library, so there's nothing in there. So when we run slicer up in a second, we're actually going to get a cold pull. So the kernel will be pulled in cold, the root file system image will be pulled in cold and then unpacked. But on subsequent runs, it's going to be much quicker because it will already be available. We are using an ARM kernel and an ARM root file system, and then we are allocating a user, or let's say a host group called tinyk3s. We're going to have 3 microVMs launched, 2 CPUs and 4 gigs of RAM each, and then we're going to back that by a file. What that means is that when we shut down, we come back in, it's there again. Also, those files are not part of a snapshotting system, so there's no parent to them. So we know they're going to change a lot, so we don't want them to be attached to some storage that's copy on write, because it just doesn't make sense. I'm then going to have my SSH keys pre-installed from GitHub, just like an Ubuntu installer. But if you want to do this statically, you can just change that and then specify them in an array. Go and have a look in the docs if you want to see how. We then have the API on, and because I'm just on my local network and I'm doing a quick demo for you, the auth is off. And then we have a SSH serial console on as well. So let's very quickly now run up. The first thing that will happen is the kernel is going to be pulled down and unpacked by containerd. This is about 50 to 70 megabytes, which is usually a lot quicker than this. Now we're getting the root file system. This could be about 600 megabytes. So it's going to take a couple of seconds to pull that down from the internet. In this case, we're coming from GitHub. And then it was unpacked. It was pulled in 13 seconds. It's now being unpacked onto the overlay file system. And then from there, it gets written into a disk image. So we've got 2 disk images, and we're fully booted up now. We've got 3 of them actually. And there we go. We've got 3 machines booted. The logs are all printed out in the lower half of the console. So now if I was to go and Control C on Slicer, it's going to shut down those VMs one by one, and then it will exit itself. Again, we can remove these logs, start running again, and this time it'll be a lot quicker because everything's preloaded, pre-cached. So still checking to see if there's any deltas on the image, mainly because in this case we're using a convenience tag, which is like a latest. There should be no changes between this run and the last one. And then we're in. Again, just like before, and if we scroll back up here, we'll see that we didn't have to unpack the image because it was already unpacked. We didn't have to clone the disk images because they were already cloned. And I have these IP route commands that are very handy. So over on my other computer, I'll run those, and then I'll be able to log into one of these VMs. One thing that's quite handy when you're doing this a lot is to edit your SSH config file or memorize the SSH keygen command so you can remove the host key, because every time that you set up brand new VMs, the host keys will change, obviously, just like in the cloud. In what we did, if I shut down and open again, these keys will not change, right? Because we have that disk image, and that's a nice way of making this portable. I could copy that disk image to this Raspberry Pi and start it up, and that would be how I could migrate the VM easily. So again, run our command, it's checking for the latest version, and they're all booted. A lot quicker this time round. So if we explore the image, we can see that there's 73 megs of RAM used on boot, but there's barely any tasks running at all. And some of the tasks we've put in there to help with commands like the top command to get system utilities back, utilization. But the system is running. There's not much load on there. The next thing that's quite interesting, I think, is to go and look at the API. Now, I have to remember. Yes, I remembered correctly. The nodes endpoint, which is also explained in the docs, will give us a devices JSON, which contains the name of each machine plus its IP address. That is handy because we can now do Ketchup Pro plan. And we can plan an installation of a cluster on there pretty quick. And then we can go and apply it based upon the YAML file that it generated. So there's the YAML file. It talks about like the Kubernetes version you want, how many to do in parallel, do you want traffic on or off, labels to allocate to these. So it's picked the first 3 to be servers. You can configure that if you, for instance, had 5 microVMs. And overcommitting isn't as much of an issue as what you'd think it would be. Perhaps if you overcommit your RAM, you could run into a crash, but vCPU is not a big issue. Now, we can just go and apply that, or there's a handy command pre-download, which downloads the K3s binary and then will copy it over to each machine in parallel so that when the installer runs, the installer gets to the starting K3s point much quicker. Now, the first server is always installed in stage 1, and then anything else is done in stage 2 in parallel. So that's quite handy. If we had 24 of these nodes, the first one would install, and the 23 after that will all run in parallel up to the amount you specified. So we already have a kubeconfig. It hasn't even finished, but because the first server is up, we can actually just go and use that if we want to. But we'll let it finish. Now the Raspberry Pi 5 is quick, but it's, you can see it's not super fast. We're getting there. Server .3 is fully joined. We're just waiting for 4. I might just shove this in the background. Okay, so there's our nodes. And we could put, oh, there we go, it's finished. We get a watch on that. And we've got all 3 up and running. So we could do things like get the pods. We see all the pods are already set up 48 seconds ago because the initial server came up and started running them all. That means we have top pod and we have top node showing us resource constraints, resources that are being used. Typically, as you might have seen in my other videos, I like to install a Helm chart, something like OpenFaaS Community Edition. And whilst that is going, I'm just going to see if I've got anything on localhost. Good, I don't. All right. So if we go and have a look on one of these IPs, I wonder if we have a node port yet. Maybe that is not enabled right now. Okay. Instead, I don't think I enabled the node port, so what I'm going to do is port forward the gateway. The gateway is still creating. If we have a look in the wide view, we should actually see what machine these have all been allocated to. So mostly, this is quite interesting, they're going on to the 2 agents or the 2 secondary servers, not on the control plane, which is the one that's got the 1 on it. That's the primary server. Okay, so it's there now. We'll just do a very simple port forward that will let us hit the gateway. We'll then grab the default password from OpenFaaS Community Edition and we will invoke the figlet function. And put my name in there. There you go. It's working. Now we could put a function in there that is a bit quicker. Let's put in the env function. This is a fun one because it gives us basically like all of the environment variables that are coming in on the HTTP request. So it's quite easy to debug stuff with this. Now I will use the Hey tool to generate some load. Let's take 5 minutes, say like 50 clients generating 100 requests per second. Great. I always seem to get Hey wrong. Let's try this again. 5 minutes, 50 callers, 100 RPS. Okay, great. So they're all running at the same time. Maybe actually on the box this time, we can run slicer VM list VM top, and this is now showing us effectively what top would show you on your own machine, but it's all going over a socket to an agent that is installed, pre-installed into all of these images. So as the traffic mounts up, we're seeing our load one average over 60 seconds is actually going up to 4. So it's more than the cores that are actually in this. If we break the screen, we'll see that all 4 of the physical cores are actually pegged right now, and they're getting a lot of traffic. The network again is oscillating up, going quite high, 1-2 megabits per second going in and out of that. Disk usage is quite high, and we've only been up for just under 7 minutes in total. This is the kind of data that you can get. So when you start to stress the VMs, you can get some feedback. Another thing that is really handy is once we do our list, we can actually do an exec and get into one of these with a root shell. And these work just like an SSH session, although it's going over a socket into the VM. This does not need networking. So I could actually have a look at the links, and I could take the link down, the one that has the main IP address. Then you'd think that this wouldn't work anymore, but it continues to work because it's a serial console. There's another way of getting into the serial console, which is via SSH if you have it enabled in your config file. We do have it enabled. But in this case, because my key is installed and that is not on this Raspberry Pi, I'm going to actually do it from here on my main computer. Is that the right IP? So many IPs. There may be a reason why that didn't start for us, or it might be that I've got the IP wrong. 96. I possibly have the IP, the SSH misconfigured, but if it's set up properly, that's exactly how it works. So you can get in, you can explore the system. Whilst it's under load, I can actually hear the fan going in the background. So why don't we come out of there? And we see that all of those requests actually got a 200, even with the community edition of OpenFaaS. Great, on a Raspberry Pi, getting absolutely caned, absolutely pushed to its limits. And probably see on HTOP now, we're back to like a gentle lull. There's still some activity because K3s at idle does use a lot of resources. Something like OpenFaaS Edge might be better on this sort of platform. Okay, so let's close it down. Control C, and they'll close one after another. The other option is we could always use a serial console to shut them down from there, or we could log into each one over SSH and shut them down gracefully. Look back at HTOP, all of our resources have come back. We're only at 250 odd megs of used RAM. And our load average is going to start coming down and down and down as we wait for it to come idle again. So, hope that was useful to you. This is a Raspberry Pi. They're not that expensive. N100s are great computers as well for running Slicer, as are old laptops. WSL can run it, nested virtualization. I saw someone running it in a VM in Proxmox. So go and have some fun with it. Join the Discord. Tell us what you want to do with Slicer and help us improve it. Thanks.